Let's see, where did I leave off? Hey Stooky, how are you? Why are you always going live just before me? It's not intentional, that's for sure. I actually wanted to go live on Friday and Saturday, but I just couldn't. Unfortunate. But I did want to go live this weekend, so it is what it is, I guess. What are you working on today? I'm gonna keep this here because I do want to use this eventually. JM scheduling? Okay. Yeah, I know. You're just kidding. I know. But on a serious note, I do try to stream around other streamers, so we don't coincide sometimes. It's early, but I'm getting anxious. Oh, that sucks. Well, I hope you feel better. I think don't drink coffee. That might make you more anxious. I got the Tigger mug today. I haven't really been seeing, or maybe no, I have noticed streamers, but I feel like I haven't noticed a lot of math streams lately. Why does Twitch think it's okay to play the same ads twice back to back? Do you get ads? Fair enough, but at least on my end, I'll probably be switching schedules soon. Do you have any plans for post semester? I will be streaming a lot. Actually, probably will be streaming mostly daily. I'm gonna grind through the rest of this measure theory stuff, and then maybe I'll do a little topology, maybe something else. I'm still thinking about what I'm gonna do next. Um, and I'm gonna play a lot of games, I guess. I want to like to get a lot of games out of the way that I've been kind of um that have been on my list. Study time, get her done. That's right. How you doing, Justin? How's your Sunday? What about you? What's your plans? What's your winter plans? Oh, the pre-rolls. I actually didn't even know that even happened for me. Dang, I guess that is a thing. I mean, Machine Rex. How you doing? That sucks, man. I was hoping there would be no ads, but I guess turning them off doesn't mean pre-rolls don't don't activate. I'm roaming down to my mom's house starting on December 12th. Nice. Where is that? Like, is that in where what state is that in? I have no idea how much time I'm going to have once I'm there. Sounds like a fun time. Location redacted. I will be out of state during the winter too. Well, I will be out of state. I'm not sure if you will be. I will be in Missouri for about a month. How you doing, Rex? Yeah, the one thing I don't like about Twitch ads is how I feel like they're awful. Like the YouTube ads are for some reason better. I don't know why. Let's see. Okay, I resolved this issue last time. Well, I didn't do it last time, but I've resolved it since last time. This is intentional. You're not writing. We don't write it as the inverse function so that we can work with both the extended reels and the reels using the same definition. All good. Drawing comics. What kind of comics? I wish I could draw. That's the one of the skills I'm most envious of is drawing. Actually, when I was younger, I used to want to be an artist when I was younger. I drew a lot and then I didn't get a lot of encouragement, so that drive kind of like died out over the years. I even took an art class. It wasn't the art class I was expecting though. You want to enter Webtoons contest? Webtoon. Oh, interesting. What kind of comic are you drawing? If you're okay with sharing. Like what kind of genre? Making a comic series about the origin of the dragon and Phoenix. Ooh, that's cool. Are you gonna share when you're finished? Okay, I gotta skim past this stuff. Alright. Now I can finally continue the measurable function stuff again. I haven't looked at this in like 2 weeks. I wish every episode. Nice. Looking forward to that. That's cool, Webtoon. I didn't know about this to be honest. Webtoon shop? Oh, interesting. Dang, $90 for a jacket? Holy moly. You can read comics on there for free? Ooh. This is interesting. They are vertically aligned so you can just keep on scrolling. Oh, that's cool. How do I get out of the shop? Hmm. Interesting. Once you go into the shop, I feel like it's hard to get out of the shop. Unless I like actually push the back button. That scared me. That always scared me. Thank you. Thanks for the follow. Cap Catten? Gotta lower that volume when I have the chance. Let's see. No worries, it's not your fault. It's 100% mine. But I had that ping so that I can recognize when someone follows because I don't have like an obvious alert. Let's see. I respect you so much for doing maths without numbers. Thank you so much. It's no big deal. It just takes a little practice. Are you doing linear algebra? I'm actually doing analysis. Although I do like linear algebra a lot. But this is analysis. It's called measure theory specifically. How much math are you familiar with? Like, I mean, you obviously know linear algebra, but how much more do you know? Let's see. More a geometry person? Have some background in physics? Oh, nice. What's your favorite topic in physics, if you have one? But not anything too extensive, like wave function calculations and stuff, or a transform. Oh, cool, cool. Yeah, yeah, yeah. Those are very cool. Very there's a lot of applications to those. Yeah, you see that like a lot in like signal processing, right? And like sometimes even in manipulation of like photos. Okay. How'd you find me, by the way? You're just browsing the co-working category? Okay. Just going to do this. Oh, you're just browsing. Yeah, I'm a structural biologist by trade, and I use X-ray to solve the structure. Oh, that's cool. I needed a body double from my thesis defense PowerPoint. So are you in a PhD? Defending a thesis. Oh, finish off my master's at the moment. Oh, I see, I see. Are you in your final year? Like me? I'm in my final year. Measurable. Yay, nice. And PhD too? No, my journey is gonna end at a master's. I've thought about doing a PhD, but I don't think um, a PhD is for me. This is the last thing for our master's. Nice. In a different universe, I would be working on my PhD. Ooh, too thick. 3.5. Okay. Rex, are you a grad student? I don't think I've ever asked you this. There's a lot of cool intersections between physics and math methods and structural biology. Yeah, I feel like you would like know a lot about that. That's more of your jam. Let's see. What was I gonna do? Oh yeah, I was looking at this book. So last stream I said I was gonna work on this one, and then I think maybe this one today. The following proposition follows from its predecessor by recalling that for a continuous function on a measurable set, if if O is open, then F inverse of O, which is the intersection of E and U, where U is an open subset of R, so O is measurable. Oh, interesting. Okay, let's write it down. If E is measurable, then every continuous function mm, f from E to R is measurable. I've been a little lazy with organizing my notes. I need to like do that. Although I'm not doing a PhD, I do plan to continue learning a lot of math when I'm finished. So maybe that's going to be the same experience, but maybe not. Who knows? Because there's obviously research associated to PhD. And that part's probably something that I'm not going to be able to replicate. Okay, okay, continuous. Okay, that's the hypothesis. Oops. Subscription. Thank you. Now you can enjoy my cool emote. Don't thank me. Okay, so um, okay, so this is hinging on a real analysis of one fact. Since f is continuous, f inverse of g is open. F inverse of G is open for every open set G, I think. Yeah, I'm pretty sure that's what it is. Actually, this is how you define continuity in topology. It's defined literally this way. But in analysis, it's kind of defined a little bit different. It's usually defined using like epsilon deltas. And then you typically prove that um, the inverse image of an open set is an open set as well. So this is true from analysis, like under analysis one. Okay. And then we know, what do we know about measurable sets? Oh, this is measurable functions. So we do know something about measurable sets, and I think it's in properties. Where is it at? I think it's this one. Oh, I still haven't fixed this. Oh no, that sucks. I have to remember to do that. So we have here, every interval is measurable. So including the open intervals. So since every interval is measurable, so F inverse of G is in the, it's a subset of E, so you can write it as, so note, I think this is in the book, right? Yeah, it's right here. So F inverse of, I call it G, is the intersection of E and U. And U is an open subset, so it's basically explaining the proof. So note that F inverse of G is equal to E intersect, what do they call it here? U? E intersect U. And so we know since F inverse of U of G is open, U is open. Did I prove that open sets? I mean, you pretty much get it for free from the fact that the intervals are measurable. But I could have sworn we did open too. Yeah, there you go. It's right here. Every open set and every closed set is measurable. Okay, so thus U is measurable. So if it's not clear why U is open, it's because F inverse of G is a subset of E. So you basically have like two cases. So this is E, and then this is R. And then we have this little set, open set G. So it's like this, something like this. It's not going to be exactly, it's like, this is just an abstract construction, like a visual aid. So this is the map from E to R, and then the map's like this, something like this. So this is F, and this would be F inverse. And then we have this right here to be F inverse of G. Hey Luna, how are you? How you been? So um, basically if this is equal, so we define F inverse of G as the intersection of E and U, where U is in E. So since U is a subset of E, the intersection is basically going to be the same as F inverse of G. So it's, we're saying here, since this is open, this has to be open because they're identically the same. And if it just so happens that U is the whole domain, then that implies that E is also open. So it would basically be E intersecting itself. And so E would be open and measurable, but that's like, like the easiest case. So U is open because U is either going to be F inverse of G itself, or it's going to be E itself. And in both cases, we get that U is measurable. And then that's basically close to the end of the proof, right? Because since E and U are measurable sets, E intersect, we'll just say this, F inverse of G, which is equal to E intersect U, is measurable. By closure of intersections. And so the previous thing that we proved here is related to open sets. So the last result was saying that um, if F is defined from E to R, where E is a measurable set, then F is measurable if and only if for every open set G, F inverse of G is a measurable set. And so what we're doing is we're going in the reverse direction. So we've established that this is measurable and we have this requirement fulfilled, so that means we get that F is measurable. So by result 3.4, F is measurable. Easy. Okay, there's one down. Okay, so I've got that continuous functions um, are measurable functions. The next thing is that if E is a union of A and B where A and B are measurable, then F is measurable if and only if its restrictions to A and B are measurable. Okay. We're finally getting to some of the good stuff. Compositions. Okay. Okay. Guess let's write it down. Result 3.6. Hmm. Ooh, poor, I'll measurable. Okay. Rex PhD? That's what I'm wondering. How's it going, Pen? You're streaming today, right? Tonight? Let's see. Algebra tonight, yeah. I've had some requests to discuss diagonalization, so I might do that first. Nice. I just had someone in my chat um, bring up linear algebra. Also applying for some Gen AI jobs today. Interesting. What is that? Gen AI? Gen AI. I know gen is general, I'm assuming. But what does that mean? Hoping I land one at XAI. Work for Elon. Nice. Well, I wish you the best. Remember me when you make it big. Remember the little guy. Let's see. I'll add you to my team. I'll be the guy doing measure theory in the background for whatever reason. In particular, if E naught is contained in E, or it's a subset of E, and the measure of the difference between E and E naught is 0, then F is measurable if and only if F defined on E naught is measurable. Hmm. Let's see, what's the proof saying about this? Okay. Hmm. Do I want to break this up into two results? Hmm. Yeah, I'm having an issue with this statement here. Why are we assuming that the measure of E naught is 0? I don't know, I don't know. I think I'm just gonna break this up into two results. I feel like this is a corollary to the first part of this proposition. We'll see, we'll figure it out. Okay. So we have both directions to go. Okay, let f from E to R be measurable. Then um, oh, they're using less than. Why am I using greater than? I'm using greater than because I think I used it in the beginning. Yeah, I'm using greater than because of the beginning. Okay. So for every C in R, this is measurable. Okay, and then since we can write this set as the intersection of two measurable sets, oops, getting carried away here. Okay, since this And A, B, they're all measurable. Okay. That's the right side, so we prove that if f is measurable, f is measurable on E, then f is measurable on A and on B. Now we have to do the reverse direction. So that f on A. Should I write it like this? I mean, the book is writing it like this. So maybe maybe it's okay to write it like this. I'm more used to the notation that if you're going to restrict on a domain the same function, then you would write it like this. So let this so since they're measurable, then for every C R, Okay. Okay, since E is equal to A union B, and then by closure of unions, this set is measurable. Thus, F E to R is a measurable function. Okay. So I'm right here. Went through all this. Um, I think some of the details are a little bit loose here. I could have justified this a little bit more, but this is just kind of like set theory stuff. Um, the notation here, guess it's fine. Okay. Now let's see if this is truly a corollary. I'm gonna call it a corollary for now. Um, this is for 3.6. Okay, let E naught be a subset of E, and the measure of E minus E naught go to 0. Then of f of E, the function the function f on E is measurable. If and only if. Okay. We'll work through the proof and see if that line with the measure 0 is, we can figure that out. Okay, I'm gonna go this way first. Is this such thing as a negative measure? I don't think so. I'm pretty sure there isn't, because measure is defined on um, the positive reals and including 0. Unless there's something out of the scope of this book that is that allows for negative measures, but I don't think that's the case. Let's see. Let's look at abstract measures. General measure spaces. Integral measure, general measure spaces. Yeah, it's typically defined on this interval. I don't know if that's always the case, but from what I can tell, that is, as far as I know. Um, I think this doesn't have to be on R though, so there is probably a way to like work with non-real valued functions or non-real sets and create some sort of set function that maps um, to zero to the set 0 to infinity. Hey Pabs, Meowdy. Is that a new emote that you're flexing? I wonder if I'll go over this. I've been debating if I wanted to go over this because the treatment of measure spaces or just measure theory using sigma algebras was, I kind of already did it in Axler's book, but I was thinking maybe I should do it again just to kind of solidify it. But I don't know. I'll decide that later. I'll decide that in the winter. Winter's coming. Where was I? I was on here. Hey Luna, how are you doing? Maybe. Had a golden kappa last week. I know. I always like every now and then when I see a hype train that has golden kappa, I'll contribute like maybe $1 just for the golden kappa. But it sucks that it only lasts for a day. I wish it lasted for like a week. Welcome to class this fine Sunday morning. Honestly, this is the way I prefer to learn. Low pressure, on my own time. I know it's not always like feasible for everyone to do it this way, but like this is like a great hobby. Like for me, a great hobby to learn on a Sunday morning for a few hours and then just relax for the rest of the day. I'm good. Currently having some tea. Hope you're having a good day. Definitely having a good day. I only slept for 5 hours, but I slept well for some reason. Now I'm enjoying my coffee. Okay. So we suppose that this is measurable. Okay, so since let me think. Hmm. I'm trying to think of how to do this by leveraging the previous result. The previous result tells us that when we define it on, oh no, I think that's fine. Yeah, I think the forward direction immediately is implied by the previous result, right? Because E naught. Wait, but this depends on A and B to be measurable. So I think we need to first show that E naught is a measurable set. How do I do that? Hope your day is going well so far. It is. I came on a coffee run for work. That E is not the one. What, this E? Which E are you talking about? Are you working? The heck, you're working today? It's Sunday. Nobody works on Sunday. Okay. I always work on Sunday? Oh, dang, that sucks. Okay, there's a detail that's missing here, I feel like. Maybe it's written here somewhere, kind of like in a cryptic way. Wait, we can write E. Maybe I can write E. I'm going to use red because I'm probably going to use this anyways. E is actually equal to the union of E minus E naught. Union E naught. Hmm. Okay, somehow I need to get E's measurable. I mean E naught. I need to somehow get E naught measurable. Being department chair is tiring. That's what I always hear. Let's see. Oh man. Okay. Let's recall some things about measurable sets. So we know E is measurable. Did I prove something before? Sets with measure 0 are measurable, right? Um, okay, so sets with measure 0 are measurable. I think I have that somewhere here. Yeah, there it is. Okay, sets with measure 0 are measurable. Okay. Oh, I think that's why. It's the complement rule, right? No, it's not the complement rule. Dang it. Dang, I thought I had it. The complements are measurable. I think set difference are measurable. Okay, so if A and B are measurable sets, then A minus B is a measurable set. I think this is what we need. So we know that E is measurable. That's by the hypothesis. We know this is measurable because the measure of E minus E naught is 0, and that is implying that that's measurable. So I think we can write E naught as E minus E minus E minus E minus E naught. There you go. Try measurable sets. So these are measurable for different reasons. And so this is measurable. There you go. We get measurability of E naught. Okay. Note that E naught is equal to this. Since the measure of E minus E naught is equal to 0, E minus E naught is a measurable set. Thus, E naught is a measurable set. By, what was the result? The set difference, 2.18. And so since E is equal to this, F E naught to extended reals is measurable. Yeah, it is a corollary then. Our result 2.6, 3.6. Dang, I can't believe I figured that one out. Okay, the reverse direction. I suppose f from E naught to R is measurable. Okay, I think this is what the book is referring to. Or maybe it's not. Suppose this is measurable. We need to somehow show that E is measurable. I swear the way the book is doing it is like super. It's so cryptic. I don't even think I used this fact. I don't even know. I don't even know what the heck this is talking about. Why is it talking about measure of E not being zero? And why is it supposing that it is? Hmm. No idea. Let's see if I can figure it out without that justification. I'm pretty sure what I did here is airtight. I'm pretty sure this is fine. Okay. So might have to leverage this again. We might have to build E from measurable sets. So we have E naught, and then we need to show E minus E naught is measurable. And then we take the union, that's E. Okay, I think that's the strategy. Let's see. Is it the same thing? Oh wait, it's automatically free. What am I saying? It's measurable because it's zero. The measure is zero. What the heck? Thinking too hard about this. What's the measure of E minus E naught is equal to zero? This is a measurable set. And then since E is equal to the union of E minus E naught, E is Measurable. By closure of unions. So there we go. We got E being measurable. So we have basically this of the hypothesis satisfied, and we have, yeah, this satisfied. So that implies that this is measurable. Yeah, so that's it's a corollary basically. Hence, F from E to R is measurable. And this is by, again, result. 3.6? Yes, 3.6. Sick. I have no idea where this is coming in. Why do they say this? Take notes, Babs. Okay, I feel satisfied with this proof. I'm pretty sure it's correct. And I'm still curious on why this is all the note-taking emotes. I still don't know why this is true. If anyone has any ideas, I would love to hear them, but I can't for the life of me think of this completes um why this completes this proof, the corollary. If the measure of E naught is 0, then every subset of E naught is measurable. So if measure of E naught is 0, then E naught is measurable. Why is the subset of E naught measurable? I have never taken measure theory, so I'm of no help. Please give me matrices, give me death. Are you planning on learning measure theory, Pen? You totally should. It's really, I think the theory is very nice. Why is every subset of E naught measurable? E naught is measurable from this hypothesis, which I'm not sure why they're even stating. Every subset of E naught is measurable, and therefore every function on E naught. I think this might be a typo. But I have no idea. It's not my immediate feature since college doesn't need anyone to know it. I think advanced statistics and machine learning are next. I see. Advanced statistics meaning mathematical statistics? This stuff? Where you're just proving things about different distributions and their expectation values and their variances and stuff like that. They're what's it? The generating functions. Yep, Wackerly. Is there an errata for this text? That's a good question. I need to look that up actually. I should always look at erratas before I even read text. I don't know why I haven't done it for this one. There might be, but I'm not sure. But like this is like this makes no sense to me for some reason. It could just be like I'm brain farting because that has happened before and it takes me a while to figure it out. But the way I justified it is, I think, adequate. So I'm okay with moving on from this one. I thought this was pretty slick actually, doing this part. I'm actually pretty proud of myself for this, even though it's not a huge deal. But I was really happy that I was able to do this, and specifically because this fact, which I proved here, is not, I don't think is in the book. I literally thought of it and thought that it should be true. I don't think it's in the book. I'm pretty sure it's not. But the only reason why I thought about it was because it's like a requirement for sigma algebras, and I know that um, I know that measurable sets form a sigma algebra, so it has to be the case that this is true. But I don't think the book even goes through the exercise as far as I'm aware. But it's not very hard. It's like a one-liner. So I was very happy that I'm actually able to use this result. Are you planning to do stats? I'm actually taking a stats class right now. Um, I'm not. Are you like thinking? Are you asking me about like learning it like officially um or doing it in stream? Was curious if you wanted to collab on it. Stats is easier if you have a friend. Oh, I see. I see. Let me think about it because I I I was interested in going over it, but from like the level of measure theory, but it doesn't have to be obviously that level of measure theory. Um, I guess like one of the reasons why what I was thinking about doing is because like I have already measure theory, like um I already have it, I guess, under my, like I have it as a list of things that I have exposure to and I feel confident in. So like stats and stuff like, or probability and stuff, and that stuff is like very like the theory can be uh like having so many brain farts. I can build the theory from that just by using like all the framework that I've already established. But yeah, remind me when you like the time gets near. Um, and it's mainly going to depend on my schedule, to be honest. And if my schedule is like very pretty much free, I will definitely be interested in collabing. This book doesn't. There's like actually there is a trend in books like these where they kind of briefly talk about measure theory. I mean, not measure theory, probability. This is the book I used when I took um, measure theory and functional analysis. And so you can see that we have probability measures here, but it always begins with some sort of statement of, we begin with an intuitive, non-rigorous motivation. It's and there's another book that I was reading that also um states it like this. Actually, I can show you real quick. It is the Fallen book. It also discusses probability in some chapter. Oh, topics in probability. I don't think I'm gonna be able to. It's 313. I even highlighted it. This brief chapter is intended not as a systematic introduction to probability, but rather as an advertisement for the subject. So I was a little disappointed with these books kind of treating it kind of briefly rather than in detail. But I guess it has mostly to do probably with like page length and like having to cover so many topics in like in a book. You probably It probably deserves its own textbook. So I would just have to look at it, look for a book that treats it using measure theory. Yeah, it's not happening until next year sometime. I wanted to do regression as well, maybe some advanced machine learning methods and stats. Nice. Yeah, if it's next year, I most likely should be able to help out with that because my schedule should be much more open. Who wants to advertise probability? Yeah, the class I'm taking is like it doesn't use this book that I just looked at, but like a different book. This is the book I used in undergrad, but like the definitions are just a little bit too loose for me, and it's just kind of when definitions are loose, it makes me uncomfortable with trying to prove like theorems and stuff like that. Like it's I need a little bit more precision. I think I use the same textbook. This textbook is actually really good. It's like a really good textbook for like a first look. It's very good. And I'd actually reference it when I am working on probability. But yeah, I think the definitions are just a little bit too loose for me, to be honest. Like it's if I need to prove results, sometimes I can do it. Like I can work with the looseness of it, but sometimes it's just I just need just a little more precision, and I would be okay. Yeah, Wackerly. Yeah. Yeah, this is a great book. Right now, we're covering multivariate probability distributions for continuous variables. Eventually going to skim back through that book, then move on to his linear regression book. Cheap viewers, nice. I was looking for that. I didn't even know he had a linear regression book. Yeah, maybe I would use that as an opportunity to learn a little bit of machine learning. Hey, Pen, you're my most expensive viewer. Just remember that. There's no way to put a price on you. Okay. That is, I think I only wanted to work on these two today. It was only gonna be a 2 hour session today, anyways. Um, let's see what's ahead in the future. I should be back on Friday. I actually meant to stream 3 times this weekend, but it just didn't work out. I bet you say that to all of your audience members. Let's see. What was I at? Oh, I'm like way ahead. I was in here. Okay, so the next thing is to prove linearity of of the of measurable functions, products, some properties that we're going to basically use in integration. So basically, this whole chapter is kind of like to set up integration, because integration depends on measurability of functions. So the next thing we'll do is this. I might do monotone stuff, which is not in this book. I'm still debating, but at the very least, I'll start with this next Friday. So let's wrap this up. Let's wrap this up. And let's raid. I think Stuki's still live. So let's raid Stuki. It's Stuki time. Okay. Anyways, thanks for watching. Hope you guys enjoyed. It was very it wasn't that bad today actually. Bye bye Paps. I'll see you later, I'm sure. Take care. See you next time. See you later on. Um, bye Luna. Bye Pen. Bye bye.